1 or 2, 3, 4, 5s. I mean more than 10. So it depends on your model, right? So you can create different models and represent things. But there is a limit to this. So you can convey a lot of information, but still we have got some issues here as well.
Life lessons come one in a dozen. The other 11 get something from nothing. I sit here looking for an answer. Maybe the biggest question was in the last chapter.
So yeah, I've got books. And one of the issue is that we can't convey this information using words. So a right thumb. And I can add n at the end of the word to convey that it is a number. For example, right thumb n. So what does it mean is, I just got these number of books. So the conclusion is that our perception is limited. So in the last video, we developed some number systems to keep track of things around us. But why? Why did we even bother? Keep asking such questions. The whole point of this series is to learn math the right way. And if you don't have a system to keep track of things, you are gonna run into some serious problems. We talked about number sense in the video 0. So if you haven't seen it yet, go check it out. But before we dive in, let's imagine a world without a number system. Yeah, I know this probably should have been in video 0, but who cares? Honestly, without a number system, you probably wouldn't even have the advanced devices you are using right now. It's one of the most fundamental parts of these devices. Sure, we might have come up with something creative, but I can't think of any right now. And trust me, you'll really get how important number systems are when you are building your own computer. It could even be life-threatening. Imagine you are attacked by a group of really dangerous people. But here's the catch. You don't have a way to count them. So you start taking them down, and after a while, it seems like you have gotten them all. But you can't be sure if someone's hiding because, well, you did not count them. And then so we have got a bit of problem here. Let's keep going on our journey. In the last video, we came up with a number system, and yeah, it might have helped in that gunfight where you just, well, died. But what if you have got a ton of coins? Counting them would be a nightmare. Sure, you can count them, but we'll get back to that. We are gonna upgrade our system so we can count with ease. But first, we need some unique symbols to represent the things we are counting. If you tried using something like left foot, little toy, and to represent stuff, it would be a pain to write down just to represent these items. And it only gets worse as the number of items grows. Plus, it's a mess to communicate since it clashes with your body part names and it's just annoying to say out loud. We need to simplify things with smaller symbols. Let's do that. And don't worry, we will circle back to our number system we made before. But let's fix this small issue first. For simplicity, let's use an eye or just a stroke to represent a single item instead of right hand, little finger, and easier to communicate, right? I thought so too. And for each new item, we will just add another stroke. But if you really think about it, we can't keep doing this forever. It would end up like the stick method we used in the last video. One stick for each item. And obviously, we can't just keep going like that forever. You need to switch things up and use a new symbol. I'll stop here because that works for me, at least. But hey, you can keep going if you want to. For me, I'll use H to represent a handful of items. Now, let's take it a step back further and look at it like this. Makes sense, right? But wait, it's happening again. Things are getting repetitive. So let's break this cycle. I'll use a different symbol to represent this new group of items. We'll stick to the same method as before for representing these items. Take a moment to process it and you'll realize we are just ending up with a bunch of T again. And yep, it's happening again. Why do we keep introducing new symbols? Well, it's because we want to keep things simple. That's it. You want it short and easy, right? So whenever we hit T, 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 just like we did with the H, we will use a new symbol. By the way, here's a little challenge for you. What if we tried H, 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 H? I did not go down that path, but I would love for you to figure it out. Eventually, that would just be another number system with its own pros and cons. At this point, you could keep going, but it's never ending. So, this method eventually runs out of steam because we will always need new symbols. Think about it. You can remember only a limited set of symbols, so you can't always force new symbols, right? And if you don't, then this is a kind of conversation you can expect. Yeah, I guess T T T T T T T T T T T T T T views. Honestly, that's not my vibe. We need something better. A system that can represent any number, no matter how big, with just a limited set of symbols. That's the challenge for this video. Think about it. The question is, how do we create a system that can represent any number of items using a limited set of symbols? Let's take a step back and use our old method of counting, just using fingers, keeping things simple. Why? Because simplicity is the key. Don't worry, the method stays the same. Imagine you get the chance to meet the characters from Stranger Things in real life. To make sure none of them ditch you, you better count them before you go. And yeah, of course, you will be provided with a list of names. Now you could just grab a piece of paper and start drawing strokes, but trust me, the number of characters will grow, and that method will quickly become a pain. And let's be real, Dustin would hate it. So let's stick with our old method for now. We'll start with Dustin, and yes, both hands are right handed, so let's not worry about that. So, what's the plan? Every time we encounter a character, we will count them using our fingers, and once we are done, we'll remember where we stopped. Easy, right? So we just have to remember our finger where we stopped, and that's it. But wait, what do we do once we have used all our fingers? Maybe bring in another pair of hands? Sure, we can do that, but we can't keep going like this forever. It would just be like the old method of using sticks. Instead, let's build on this method. We'll use our original pair of hands to count, and every time we exhaust those, we'll mark it on our new pair of hands. This way, we'll need right index finger and number of markers to represent a number. For example, the left part will tell us how many times we have exhausted our original pair of hands, and the right part will mark the last finger we used. But again, we'll eventually exhaust our new pair of hands too. So, what now? Get another pair of hands? Sure, until someone starts thinking this is ridiculous. But hey, that's their problem, not ours. This is a form of abstraction, so go ahead and draw some hands in your notebook. And don't worry if your drawing skills are not great. Mine are not either. Each time you introduce a new pair of hands, it takes more to exhaust them. So we can represent more numbers using this system. But there's one more issue. How do we write this representation? If you have exhausted the original pair of hands, right, middle finger, and times, you would have no fingers left to use. You could write right, middle finger, and on the left, but what about the right part? You can't leave it like this because it could be misinterpreted. So maybe we could use the word human body end to show we have run out of items to represent. The final representation would be right middle finger N, comma, human body N. But here's a new problem. Consider these two representations. Logically, they represent the same number of items, which means our system is not unique. we could end up with multiple representations for the same thing, leading to confusion and inconsistency. To avoid that, let's define a rule. Once we exhaust a pair of hands, we mark a finger on the next pair of hands to the left and reset the exhausted hands. So we'll treat any other representation as illegal. Yes, of course we could use it, but it just would not make sense. So we are rejecting it. Now we need to refine our system, especially the words we use to represent the number of items. We can't keep using our body parts names. They are too long and confusing. So let's give each finger a special symbol and name. And here they are. I did not come up with these symbols, but now that we understand the idea, it's time to adopt them. We could have used our other symbols or even made up our own, but for simplicity, let's stick with these. I have paired them with our finger names. Notice that there is no pairing for the left index finger because we never use it in our representation. Remember, we said it was illegal, and we can represent the human body with 0, this symbol. The reason you don't need hands nowadays is that you have been using the system for a long time, I guess from childhood, so you have been practicing it a lot and finally you are just accustomed to it. So you don't really need it, but you should understand the underlying concept of it so you can use it in a better way. Consider this. I got around 60x from the market. Can you exactly imagine those 60x? Not exactly, I guess. But since I buy them regularly, then I have an idea of the volume they are gonna occupy. But the word 60 helps me keep track of them. I can count and see if I'm getting the exact number of eggs I paid for. So it's easy to track them. This is how our number system works. Let's give every position a name. We can do that. You might have studied that in school or somewhere else. It goes like ones, tens, hundreds, thousands, 10,000s, and you can go on. And 10,000 because we exhausted 1,000 fingers 10 times. So 10,000. You see, we added the letter S after the words because they count the number of tens, hundreds, etc. Think of them as a name slash label for different hands. So hundreds counter is used to denote the number of fingers used on that particular hand. Consider the number 782. How would you say that? One way is to just say 782, but another way can be 700s, 8 tens, and 2 ones. It just tells us the number of fingers used on those labeled hands. Though we say 782, we omit the word ones and instead of tens, we use ty as a suffix. And to be honest, that varies with language. So nothing to worry about. We know the underlying principle behind that. Finally, we get a system where we can represent any number of items and keep track of it. For example, your grandfather possessed some really expensive diamonds. What if he could not count them? Maybe you guys won't know if some of them are stolen or not, right? And even you may not die in the situation we discussed earlier. The crow that died in the last video could also survive. Also, the system we just came up with, well, kind of, is called a positional number system. But what exactly is that? Let's say you are using a certain number of symbols in your system. For example, we use 10 symbols in the system we just invented. Take the number 1911. Anything special about it? Not really, right? But notice how we have got 2 ones in there. If you think about it, they actually represent different values. This one stands for this many items, while the other one stands for that many. So the value of a symbol changes depending on its position, and that's what makes it a positional system. Now, what's a non-positional number system? Remember the one we invented before this? If not, just head back. For those who did not, you can try remembering the Roman numeral system. In that system, X always represents the same number of items, no matter where it appears. The same goes for other symbols. And if you are feeling curious, you can start looking into more type of number systems. Anyway, before we wrap up, Hold on, we still haven't talked about Radix or base, and that's something you really need to know before the next video. Trust me, it's gonna be important. So, what is it? Basically, the base is a key feature of a positional number system. Note the word positional number system. It tells you how many unique symbols are used in that system. For example, in the decimal system, we use 10 symbols from 0 to 9. Now, there's this common belief that humans settled on base 10 because we have 10 fingers. But if you dig into history, you'll find that humans also used other systems like base 12, base 60, and more. Coincidence? Maybe, maybe not. I'm no historian, so who knows? Although one of my friends is, so maybe we'll get her to weigh in on that.